Okay, we are going to continue with our angle equations. We're going to add a little bit of a level of challenge to these. So we're going to call this more angle equations. Okay, so our first example, what you may notice is in our angle situation here, I have two variables. I have a z and I have an x. Okay, so your first thought, you may be a little nervous, like how do I handle two different variables? Okay, now the thing is we don't handle them together. We're going to handle these two angles separately. Okay, you have options of where you want to start. You can decide, especially in this case, I can find the z first if I want, or I can find the x first. Okay, so if we want to find the z first, here's what we would do. If I look at 72 degrees and z degrees, do you see how these add up to 180? That gives me my equation to solve. 72 plus this angle has to equal 180. Now be careful with the z, make sure it doesn't look like a 2. My 2's look like z's, so I always add a little marking. If you don't, make sure that you have your 2's really look like 2's. So z would equal 108. 108 degrees. So now to find x, oops, over here. To find x, we have two options. Okay, my first option, if I look, you see how these two angles are vertical angles? They're opposite from each other. So I could say 72 degrees equals 8x minus 80. And I could solve that equation, right? My other option, if I look at this straight line, z plus this angle equals 180, right? Well, I know that z equals 108. So I could say 108 plus 8x minus 80 has to equal 180. So I have two options. I can either look at the supplementary angles and figure out my x, or I can use vertical angles. And honestly, at this point, it's up to you which equation seems more efficient or easier for you. More than likely, it'll be this blue one. There are less steps. So if I start solving, I get 152 equals 8x. And when I divide, I get x equals 19 degrees. And if you solve this red equation down here, you should get x equals 19 degrees. Okay. So z equals 108, x equals 19. Let's look at another example. Same type of situation. You can decide, do you want to find z first or x first? It does not matter. This time, let's find x first. Now, if we want to find x first, I can't use this supplementary angle situation with z and the x, because now we're dealing with two different variables. Okay, the one thing that's important is we want one variable at a time. Okay, so I can't use supplementary here. I'm going to have to use supplementary here. Okay, because these two angles also make a straight line. Okay. So I can say 109 plus 7x minus 20 equals 180. I need to simplify my left side first. So I'm going to add the opposite so that I can put 109 and negative 20 together. 109 minus 20 just doing the work on the side. We get 89 plus 7x equals 180. So again, keep solving. And I get 7x equals 91. Oops. Divide each side by 7. And I get x equals 13. Okay. Now for z, I mean, I could figure this angle out and do the supplementary here, but that's a lot of work. That's crazy when, if I literally look at the vertical angles, 109 equals z. It's as easy as that. Definitely don't overcomplicate. Okay. Not bad. Next example. Now it gets a little trickier, still not bad. One thing to remember, once we start getting these parallel lines with this transversal, and just so you know with the notation, this right here, those little double lines mean parallel. So it's telling us that G and J are parallel to each other. The other thing you may see are little arrows like this. That shows parallel. Okay. All right. So first thing I'm going to do is I'm going to mark which angles are congruent. I know these two are congruent, right? They're vertical angles. If I look at corresponding angles, these two are equal. Now I'll pick a different color. If you don't have a different color, you can do two little lines for the second set of equal angles. So going through from the very beginning and marking which angles are equal are really going to help solve these equations. Okay. So here's the thing. I do know that these two are equal because they're vertical angles. The problem with that is that I have a z and an x, so that's not really going to work. Okay. So what you may see here is that this x is one of my blue angles here, so that means this angle also equals x, right? I can figure out x because these two angles add up to 180 degrees. So 79 degrees plus x should equal 180. So now I just solve, and x equals 101 degrees. And it made it a lot easier marking which angles were equal from the very beginning. Makes things a lot easier to see. Right? So now, if I know that x equals 101 degrees, now I know these two angles equal each other. So to find z, I know that 101 is equal to 3z plus, is that 26? Can't see. Okay, plus 26. And I just solve. So 101, definitely use a calculator while you're working on these. We get 75 equals 3z. 25 equals z. Last one. First thing I'm going to do is start marking equal angles or congruent angles. There's no rhyme or reason to what I'm starting with. I'm literally just picking one and then finding the congruent angle. If I look at corresponding, that means this angle equals this y equals this one, right? Those are corresponding and vertical, which means these two equal and these two equal, okay? All right, so let's find y first. I would start with the variable that is just by itself, okay? So if this angle is y, I know this angle is also y because they're both blue. They're corresponding. So to find y, I know these two angles make a straight line. So y plus 69 equals 180. And we just solve. Y equals 111 degrees. Now, if I look here, my y is equal to my 3x plus 33. So if y is 111, to find x, I'm going to say, instead of saying y equals 3x plus 33, I say 111 equals 3x plus 33. And I solve. I get 78 equals 3x. X equals 26. So now this is putting everything together and including some multiple steps here that really show whether you understand how these angles work and how solving equations work. And that's it.